We will now move on with Neil Coles. Neil is the Blueback Investigator product manager. He's been working as a software engineer for many, many years and focusing the last 15 of them on geoscience software. He supports the development as a developer, but also a good discussion partner with the end users on how to best develop software within the oil and gas business. So Neil, I'll share with you now. There you go, perfect.
Okay, good, right. Okay, thanks, Stoffer. So welcome to using Python to generate automated QC reports against Petrel. I've got a bit of a PowerPoint to start, and then I'm going to do a demo and using Python and Jupyter Notebooks. Okay. So I've attended numerous presentations on Python recently, both internally within Cegal and externally, like with the workshops like this. And I've noticed that often it's very common to see QC plots in the notebooks that people present. And these plots are made using packages like Matplotlib or Plotly or Seaborn or any number of different Python visualization packages. And these packages make it really easy to display simple plots within your notebook. But we also noticed that sometimes the data presented in these plots isn't consistent between the different plots. So often you'll see the same data presented in multiple plots, and it'll be presented in a slightly different way. You know, it'll use a different shape or a different color. The data ranges won't be consistent. You know, there's slight variation in the plots, and that can make comparing these plots very difficult. Okay, we also noticed that sometimes within the same company, you'll get reports or notebooks presented by different team members or even different teams. And again, it's very hard to present the same data in a consistent way. You see these plots by different team members, and the plots are slightly different, even though they're showing you the same data each time. Okay, so we figured that it would be it's easy to add more control to your plots. You have to write Python code to do this. We've seen that in a couple of examples already today. You end up writing tens, if not more, hundreds of lines of Python code to configure your Matplotlib plot and set it up the way you want. And that's okay if it's just you as a single person. But if you want to make sure that your team make consistent plots, and or that your whole company makes consistent plots, then you're going to end up having to write this Python code. You're going to have to test it. You're going to have to share it, and you're going to have to maintain it. And effectively, what that means is that geoscientists are becoming software developers. Okay, and not all geoscientists really want to be software developers. Most of them want to do geoscience. Okay, we also realized that often the plots that you see are, you know, scatter plots and histograms and the likes, but a geoscientist wants to put more geospecific plots into their notebooks. They want to include spatial information that has more meaning to the geoscientist. It helps tie the story together if you can see information in the form of a map or an intersection or a well section. You know, you want those plots that you're used to using in all the applications that you use day to day, but you want to see them in your Jupyter Notebook, and you want to see them consistent. Okay, this spatial data that the geoscientist uses enriches the plots and adds extra value and extra meaning to the data that's being presented. Okay, so we wanted to see if we could come up with a way where you could use plots within your notebook, but you could have access to this consistent look and feel, and that you could make use of the extra data that a geoscientist expects to have access to when making these plots. Okay. So we realized that we already have a product that does a lot of this, and that product is called Blueback Investigator. Okay. Some of you may have not heard of Blueback Investigator, so I'll give you a quick overview. Basically, it's a powerful cross-domain analysis, data analysis plugin for Petrel. Okay, you can see some of the plots that it makes on the slide here, and it adds lots of different visualization options, so you can really control how you want to look at that data. Okay, importantly, it also contains all and relates all the spatial information for all the samples and all the data sets that are included. Okay, and it connects all this information together using Petrel templates. And what this means is that Investigator won't let you load a permeability well log and a porosity property from a model and say they're the same thing, because the templates are different, so we know that they're not the same thing. Okay, Blueback Investigator does this by making you, forcing you to create an investigation object. And by making this investigation object, effectively you've started the data cleaning process before doing any data science, because the investigation object will ensure that the data that comes from the different domains, from the wells and the seismic and all the different data types that Investigator supports, are included in the investigation, that consistent measurements have been used, consistent units are used, that the sampling of the data is the same where it needs to be, and that all of the data samples are spatially located within your local coordinate reference system. Okay. Importantly, it even lets you resample some of your data. So if you're trying to do data science and data analysis on well log data, it can actually be very difficult if you load the raw LAS files, because they could have been measured at different times or measured using different tools, and they could have different Z increments, different Z steps. Okay. Investigator has the option to resample this onto a common Z step, but importantly, it will also honor any gaps that you might have in your well log data. Okay, so you're not just applying a simple interpolation or spline through the points and making up data over the gaps. It's consistent. It's not the knowledge that we've built into it about geoscience to enrich the data and make sure it's available for data science. Okay. Blueback Investigator as a product has been out for 7 or 8 years now, but last year we released Investigator Pi, and Investigator Pi was an extension to allow data scientists to access these investigations that they've made in Petrel, but access them from Python inside a Jupyter notebook. Okay, and this allows you to then take that cleaned data set that you've already made in Petrel and start to do data analysis on it. You can do further data analysis using all the Python libraries and packages that are available, and you can run regressions and classifications and train models on your data in Python that you can't do in Petrel. Okay. Importantly, Investigator Pi also lets you publish these trained models that you've made, these functions, back to Petrel, and they can be run by another geoscientist inside the Petrel environment to actually classify data. Okay. So how does this relate to reporting? Well, what we've been prototyping is an extension to Investigator Pi for reporting. And this extension allows you to make histograms and box plots and bar charts that you can make in other plotting visualization engines within Python, but also allows you to display log tracks, so well section views or intersections or 2D maps of data based on the spatial information that you've used to enrich your investigation object. It's got a very simple Python API. It's concise, and hopefully it allows you to focus on what you want the data to show and how you want to present it, rather than worrying about how you manipulate the plot and writing all that extra Python code. Okay. Importantly, all of the rendering for the reports and the plots occurs in the back end. So all of the rendering that you're going to see here has actually been performed inside Petrel, which is where the data is located. We've not had to export all that data from Petrel and load it up into a Python data frame. You know, we could be talking millions and millions of samples over multiple dimensions for some of these models and grids. Okay. You can transfer the data to Python if you want to do further analysis on it, but you don't need to if you just want to generate images for reports. Okay. We're currently targeting a modeling QC workflow. Okay, and that's what I'm going to show you today. But we believe that the functionality that we're showing here is general enough that you as a user can have the flexibility to make the plots that you want to visualize the data for your workflow in the way that you want to. And you can be confident that these plots are consistent with what you would be using if you were running it in Petrel, because it's the same code, it's the same rendering that would happen if you were running it in Petrel. Okay. So for this modeling QC workflow, I've got an investigation that contains some well log data and some model properties in a grid. And of course, it's included all the extra spatial and trajectory information and definition of all the cells in the grid. Okay, so let's go over to the demo. So we can see I've got Petrel running. I've loaded the Groningen field here, and we're going to look at this subset, which is highlighted by the red box. Mainly just so that it's hopefully fairly responsive when I'm doing this as an interactive demo. Okay, if we go to the notebook, I've accessed my investigation from my Jupyter notebook using SeagalHub. So hopefully you saw Sebastian's presentation earlier today on Python Tool Pro, where he showed the use of SeagalHub to access data from within a Petrel project using a Jupyter notebook. And he showed you that you could run that with that either all locally or with your Python environment in the cloud and Petrel locally, or in lots of different combinations you can run SeagalHub. I'm running everything locally here. Okay, so I've already used SeagalHub to open Petrel and to load my project. Okay, so we can just skip over all of that because you don't really need to see all that. And first of all, I'm just going to make a simple crossplot. Okay, so this is very similar to what you can make in Matplotlib. And I've not specified any parameters. I've not tried to define how I want this plot to appear. So it's just showing me the first two continuous variables plotted against each other with the points covered by the two different data sets. The red points are the wells and the blue points are the model grid. Okay, so that's all good. But if I want to think about reporting, I want to ensure that the different reports and images that I make are consistent. So, you know, Poro Final Cegal Base isn't the best name for a continuous dimension. And I want to try and make sure that no matter which Petrel project I'm using, I always call that porosity. And I always call SW, water saturation, as S with a small w. So the first thing we can do is we can use Investigator Pi to clean up the investigation, to just prepare it for reporting. So I'm going to rename some of my continuous dimensions. I'm going to set the precision that I want the different units to be displayed in. So I want decimal places or significant figures. I can set what units I want to use in my plots. I rename my discrete dimension here. So I've already started tidying it up. If I now look at it, you can, well, it's already looking a bit cleaner. I think it's got porosity. Yeah, okay, fine, nice. I'm going to create some useful variables. This is basically just to make it easier for me later on, so I don't have to remember what everything's called. But I want to do a modeling QC workflow. At the moment, I only have my raw well log data and my my model loaded. So the first thing I need to do is I need to create my upscaled cells. So I'm going to use the trajectory information for all my wells, and I'm going to find the cells that intersect that trajectory, and I'm going to create a new set of data sets called upscaled. Okay, I'm going to set that I want to display them using different shapes and different sizes. And I'm going to set the priority. That's basically just to make sure that I always see my upscaled cells on top, because there's far fewer of them than all the rest. And you can see now I've got these triangles, and these triangles are my upscaled data sets. Okay, so if I want to start thinking about the reports that I'm going to make, I want to start thinking about the plots I'm going to put in it. And everything in Investigator Pi reporting is controlled by a view. So if you want to customize how the plot looks, you make changes to the view. So the first thing I'm going to do is I'm just going to create a view, and I'm going to set that how I want, what data sets I want to be displayed. I can set how the count axis is on my histograms. I want to apply weighting to my histograms to take into account the cell volumes for my model, and I want to turn legends on and things like that. Okay. Importantly, I can also copy these views. So I can take my base view here and I can make a copy of it, and I can make some changes. So this time I've set that on top of my base view, I only want to look at the porosity information, and I want to have a different histogram for each of my fascies. So I've now made a weighted stacked histogram showing my original well log data, my upscaled and my model properties, and I've divided that histogram into my conglomerate, my shale and my sand plots. So I can see that, you know, my raw well logs and my upscaled cells are pretty similar, and actually it's been a fairly good job so far of doing the model. You know, I'm happy with that. What I might want to do though is look at a more complicated plot by zone. So I'm going to make a box plot now showing me all the statistics for each of the properties by zone. So the bars, the zones are highlighted with a background color, and over the top of that, there's a box plot for each of the different data sets showing the full range of statistics for those data sets. So I can now, that's a nice report. I can or a nice plot. I can include that in my report. I'm fairly happy with that. And I've only had to write, you know, I don't know, a dozen lines of Python. It's been fairly easy to get a complex report made, and I know that that report is going to be consistent if I display it on different data sets or on different investigations. Okay, I could look at a fascist proportion plot. So again, I'm going to do the same, but this time rather than looking at the continuous variables, I want to just look at the proportion of fascies in each zone. So I can now see the how the fascies proportion varies between my raw well data and my upscaled and my grid properties. Okay, so this allows you to tailor the plots that you want to make for your reports in a simple way. So again, I can make a cross plot view, and I could display a simple perm plot colored by water saturation of my fascies. Oh, well, that's quite pretty. I quite like it. You know, I can see the variability in water saturation, but I can't really delineate on this plot very easily between my wells, my raw wells, and my grid properties. So instead, this time I'm going to use two views. So I'm going to make a multi-plot, and in the first view, I only want to see the raw well data and the upscaled wells, and in the second view, I want to see the upscaled wells and the grid. And this time I've colored it by fascies. So there you go. So I've made a multi-plot now showing wells versus upscaled and then upscaled versus grid. Okay. I can do the same. I can make a simple matrix plot. So, okay, it's okay. It's a bit crowded. There's an awful lot of data there. I'm not really sure that tells me very much. Maybe what I want to do instead is to look at the mean values for each zone in the matrix plot. So I'm not going to plot the raw data this time. I'm just going to plot the mean values for each zone and see how they compare across each of my continuous properties. So, okay, yeah, that's maybe got more information. It's easier to understand. So all of those plots that you've seen before can be easily made using Matplotlib or Plotly, you know, as long as you're willing to write the required amount of code to configure it the way you want. But you also want to make more geospecific plots. So this time we're going to take the same investigation data, and I've selected a couple of wells, and I'm just going to make a small well section window showing my well logs plotted. Okay. That's good. Now I know that my zone colors here are the same as my zone colors were in my box plot above, because it's all based on the same investigation object. So no matter how we're displaying the data, it's always consistent. Okay. But rather than displaying it grouped by well, like I've done above, I might want to actually see it grouped by property so I can just compare them. Yeah, okay, well, good. But what I really want to do is have a look at a well, and I want to see the raw well data plotted next to my upscaled data. That is much more interesting. Right, good. That would be a good plot for me to put in my report to show how well I've modelled this field. And importantly, again, the colour scales here match. So the colours for this saturation curve match exactly the same colour scale that was used in my cross plot above, where I plotted my data and coloured it by water saturation. You know, I don't have to do anything special, it just happens. It's part of the investigation and it's consistent. Okay. Optionally, you can also now make intersections using Investigator Pi reporting. So this one is going to take calculate a north-south intersection at that easting, effectively, and it's going to find all the cells that are intersected by that line, by that plane, and it's going to render them as an intersection plot. So you can see here, and I've selected porosity as my property. So, and again, it's the same color scale. So that my porosity values here, the green here matches the green in my log tracks, matches the green in my histogram or my matrix plot, depending on what I've shown. Okay. As well as north-south intersections, of course, I could make east-west intersections. Here I'm going to plot all of my property, well, not all my properties, I'm going to plot some of my properties. And I know that Investigator Pi has made these plots the same, so the axis ranges are the same for all of these different plots through my intersection. Okay. Finally, as a geoscientist, often we look at maps. So we want to take the same information and we want to look at it as a map. So this is a 2D slice. So first of all, I'm just going to create a 2D slice through my model every 50 meters. Okay, so there is a slice through my model at 2750, 2800, 2850 and down, and 3000 is pretty much the bottom of this model. So some of the pillars fall into it and some of them don't, which is why you get this funny pattern. Okay, so that's at a fixed Z through my model grid. I could also look at it at a fixed K. So this is now a varying Z, and my first K25, well, that's in my shale overburden, and there's very little porosity there at all. And you can see that as you get deeper in the model, you get more into the reservoir sands until you effectively fall out the bottom. Okay, and over the top of this, I've also illustrated where the different well bores can be found and the symbols for them from Petrel. So that was different slices through the model, but often we want to aggregate information about the different zones. So rather than a slice through the model, this time Investigator Pi is going to take all the cells that fall within a zone and is going to calculate a thickness map for each of the zones I've requested. And again, it's coloured in a consistent way across all the plots. And as well as making thickness maps, I can make I could find the mean porosity, for example, within a zone. Okay, so what I was trying to show here is that you can very easily make lots of different plots based on your geo data that you've already got from Petrel, and you can present them in a consistent way with very few lines of code in your Jupyter notebook. Okay, so that was the demo. So what report did I make? Well, I'm going to show you in a minute, but I've used Investigator Pi functionality to basically force a standard set of names and colors and shapes and precision and units onto the data from Petrel. So it doesn't matter what the last user who made this investigation, how they had it set up. I've overridden that, and I'm going to use what I want to display in my report so that I know it can be consistent. I could run this report on multiple different Petrel projects, and I know that they would always come out with the same names for the different continuous dimensions, the same colors, the same shapes. Okay. Having worked out what the little snippets of Python code I need to make the various plots, I can also group them together within my report template, and I can use loops in Python. So I can repeat sections of the report very quickly and very easily. Okay, and again, I know that all of these plots are going to be consistent. And then I can use a technology called paper mill to effectively programmatically run a notebook and parameterize it with different information. And I can execute that notebook behind the scenes if I want. And when I run my report generation notebook, my report template, I'm going to generate hundreds of plots in a matter of minutes from Petrel. So here is my example report. So I've got a section for each well. So for each well, I've shown a small map showing where the borehole is located. I've made a well section window showing my raw data versus my upscaled well logs. I've done a matrix plot of my continuous properties. Again, this is just a raw well versus upscaled well. I've made that box plot that I quite liked. And I've made a Fascist proportion plot as well. And I have repeated that for every well in my investigation. And I've made all of these images. Okay. I've also made a similar set of sections, if I can find them, there they are, on my upscaled versus my modeled property. And in this set of sections, I've got the same matrix plot, but I've presented a box plot of the Fascist information, basically, within that zone. And I'm repeating this for every zone. So I can see how well my my upscale data has been distributed through my grid using my geostatistics, and how my different fasces compare and my different properties compare. Okay, and again, I can do it. I've got a section on intersections, which are all through the model, and I've got a section of maps as well. So for every zone, I've made a depth map, an isocore, a mean porosity map, and a fasces map. So this is my overburden. So as I get deeper, you can see that I have more fasces and I have more average porosity generally. Right, so what are we going to do now? What are our plans? At the moment, this is running inside Petrel. We'd like to run independently from Petrel. We're only running inside Petrel basically to get access to the data. And once we've loaded that data into Blueback Investigator, we don't actually need Petrel. We're not making use of Ocean. We're not using Petrel for anything else at that point. It's just providing a source of data. So we could run this, and we have a prototype where we can run this externally to Petrel. Therefore, once we've exported the investigation object, which we can do, we can close Petrel and we can release the license. Okay. We want to integrate this with Python Tool Pro, so that you can use Python Tool Pro to interrogate other data within Petrel, and you could maybe combine data from different Petrel projects using Python Tool Pro and SeagalHub, and you could then make reports and plots combining that information together. And if we can make it work on data frames, which we have a prototype where it does, then effectively we can base it on any data source. Now, you would have to find a way to get all the geospatial information in, rather than just the sample data, if you want to use more of the geospatial plots. But we're working on that. All the report plots that you've seen in this demo have been static. They're just bitmaps. But we're also working on a widget that would allow us to embed an interactive plot within the notebook, so that actually you wouldn't even have to write those dozen lines of Python code to set up the plot. You could get presented with a small web UI effectively within your notebook, and you could toggle options by clicking on radio buttons or moving sliders or checking checkboxes. And then at the end of that, you could export the little snippet of code that you need to generate your report programmatically. But you could actually determine what that snippet of the view, how the view is defined interactively. rather than with Python. We plan to release this static reporting in the next release of Investigator, which is 5.4. And we hope that this would allow you to spend more time focusing on the geoscience and less time worrying about how you're going to make reports and images for PowerPoints, and get back to doing the geoscience. Don't worry about the data manipulation like this. Okay, like all our products, we are client driven. So I'm looking for feedback. Please tell us what you think. If you think this thing's missing, we look forward to hearing from you. Okay, any questions?
Thank you very much, Neil, for your presentation. It certainly is an interesting thing for me, especially when you work M&A, looking into multiple models. And one of the questions raised here is it possible to run this on multiple models at the same time, so you can tie it up to X number of models, if you like, and then do the reporting?
Yes, it is. I only showed one model here, basically for speed, for doing the demo interactively. But yes, we could have loaded multiple models together, and we could put the plots side by side. That would be perfectly feasible.
I see there's just a few minutes, and I need to rig for the next presentation. I see there's a few additional questions. We will share these questions with Neil, and we will then provide you answers in a very short time. So again, Neil, thank you very much for your presentation. It's always interesting and exciting to listen to you.